Welcome to this video in which we are pleased to present to you the geologic evolution and mineral deposits of Nevada on a brownie, a geology lesson you will never forget to eat. My name is Lucia and I am a geologist with the Nevada Division of Minerals. This lesson was developed with 3rd to 6th grade in mind, so we tried to keep it simple. Let's get started. Most of the graphics you will see in this presentation are from these two fantastic books, Ancient Landscapes of Western North America, A Geologic History with Paleogeographic Maps, and Roadside Geology of Nevada. They are both great references for any geology enthusiast. Here are the materials you will need to follow along with this video. You will need a brownie that is lightly frosted, 7 different colored markers to put point features on the brownie map, chocolate morsels, and Twizzlers, the ones you can pull apart into thinner stringy pieces. We used Skittles and Nerds for our markers, which seemed to work great. We did not end up using the sprinkles, but they would have worked just as well. Chocolate morsels were used for the mountains, and Twizzlers were used to mark the faults. Everything was purchased at the grocery store and was under $20. There was enough material from the candy purchased to do the activity with at least 6 more brownies. Every good brownie map must have a legend. This is an example of a legend made for this activity. This also shows you exactly what you will need to build the brownie map, so take a moment, gather and sort your supplies, and construct your legend. Nevada's rocks record more than 2 billion years of tectonic and geologic history. There have been many major events that have made the landscape of Nevada what it is and generated suitable geologic locations for lots of different kinds of rocks and minerals to occur. The oldest rocks are found in the East Humboldt Range in the northeastern part of the state and are thought to be 2.5 billion years old. The red star on the map shows their approximate location. It is hard to wrap the brain around 2 billion, at least it is for me, so let's try to get a visual. For all calculations involving brownies in this presentation, I will be using a 1-inch long by 1-inch wide by 1-inch thick brownie because I like easy math and big numbers. If we had 2 billion brownies, we would need 1,250 20-foot long school buses in order to transport them anywhere. Well, actually more if we wanted a driver. The oldest, bottommost rocks, also known as basement rocks, of Nevada were part of the ancient supercontinent called Rodinia that existed about 1 billion years ago. Around 700 to 600 million years ago, continental rifting, that is, where tectonic plates are pulling away from each other, tore Rodinia apart into several smaller continents. Find the continent called Laurentia and look to the top edge of the continent. A very small red Nevada is shown in the screen where the black arrow is pointing. The edge of Laurentia ran right through the center of what is now Nevada. The map in the main screen is a paleogeographic map, or a map that shows the interpreted geography millions or billions of years ago. On the right-hand side of the screen is a geologic timescale. We will have this as a reference for the remainder of the presentation. This timescale, when printed, is a double-sided bookmark. One side represents the Precambrian, or from 4.6 billion years ago, the beginning of planet Earth, to the beginning of the Cambrian, about 542 million years ago. This is the only slide where we will discuss the Precambrian. The rest of our discussion is from the beginning of the Cambrian to present time. This paleogeographic map is showing what scientists believe to be the edge of the continent 1.6 billion years ago. The edge ran right through what is now Nevada. How do scientists know this? Simply put, they used isotopes and isotopic analyses along with geologic knowledge. Scientists use isotopic compositions of elements like strontium, neodymium, lead, and oxygen in rocks as tracers for the presence of other kinds of rocks because these isotopes are released as the rocks age and decay. On our Brownie, we will use NERDs to show the trace of the edge of the pre-Cambrian basement rocks, or what is the shoreline running through Nevada in the screen. Rifting also generated many large northwest trending faults, along which many of Nevada's largest gold deposits are focused. Ore fluids use faults as pathways or conduits to the surface. We will come back to these faults later, but use the Twizzlers to lay a few northwest trending faults in the approximate locations shown on the map. We will be stopping along the way to show the progress of our Brownie map. Here is what your map should look like at this point. Throughout the remainder of this presentation, there will be cross-sections shown at the bottom of the slides. A cross-section is a tool geologists use to interpret what is going on below the surface. Think of it as cutting a cake open to see what's on the inside. We will not go into detail on these, but they are there for the viewer to see things from a different perspective. After the main rifting event, ocean levels rose and Nevada was covered with water. Eastern Nevada was a carbonate shelf, similar to the Bahamas, but without the people. This shallow water carbonate shelf lasted for about 200 million years, and it is thought that this long-lived stable environment is part of the reason life was able to really grab hold and diversify. A thick sequence of marine sedimentary rocks were deposited, which would both be the source and host rocks for many later ore deposits. Some of the Cambrian and Devonian sedimentary rocks host non-metal deposits as well that are currently being mined today, including quartzite, limestone, and barite. Use the appropriate non-metal markers to put the mines shown on the screen onto your Brownie map. During the Devonian, in this quiet Bahama-like environment, disaster struck when a large 3-mile-wide comet or meteorite smacked into planet Earth right into what is now eastern Nevada. This is known as the Alamo impact. The resulting crater was over 30 miles across. Huge tsunamis occurred and layers of broken rock formed due to the impact. These broken rocks record this event and can be found in the Shell Creek and Hyco mountain ranges. Use the chocolate morsels to put these mountain ranges onto your Brownie map. An orogeny is a mountain building event. The antler orogeny put an end to our quiet Bahama-like environment. The antler orogeny took place during the late Devonian and lasted through the early Mississippian. The orogeny pushed or thrust deeper water rocks over the shallower water rocks that were forming close to the continent. Bedded barite deposits in Nevada are hosted in these deeper water rocks. Rossi is a barite mine that fits this bill. Place a non-metal marker on the Brownie to represent the Rossi mine. Mountain building created an uplifted area referred to as the Antler Highland. The Toyabe, Hot Creek, Diamond, and Independence mountain ranges are among the ranges that are part of this terrain. Use chocolate morsels to represent these 4 ranges on your map. What goes up must come down, and when collision and uplift stopped, the Antler Highland began to erode. From the Mississippian through the Pennsylvanian, the rocks which made up the highland were shed into a basin that was created to the east during the orogeny. This basin is referred to as the Slide Mountain Ocean. Organic rich rocks deposited in this basin are the most important source rocks and reservoirs for oil in the eastern Great Basin. Place a symbol for the oil fields shown on the screen onto your Brownie map. Brownie map checkpoint. Here is what your Brownie map should look like right now. A subduction zone is where one tectonic plate is being pushed into and is sinking or subducting underneath of another plate. As a plate sinks, it pulls really hard on the plate it is sinking beneath, and things can rip open in the overriding plate. These things that are ripped open are called basins. During the Pennsylvanian, a subduction zone off the coast of Nevada started pulling things back to the west and created another basin, this time on the west side of the Antler Highland. This basin is referred to as the Havala Basin. The Havala Basin was then filled with sediment that later turned into a thick sequence of rocks, now referred to as the Havala Sequence. The Havala sequence is host to a different type of ore deposit which hosts small amounts of copper and silver. These deposits are formed due to metals that are spewed out of black smokers. All the smoke that one sees coming out of a black smoker on TV, that smoke can have metals like gold, iron, or copper. Black smokers form underwater where magma is really close to the surface. If you look at the cross section at the bottom of the screen towards the left, you can see the Havala Basin with arrows pointing in opposite directions indicating the basin is being pulled apart. When the crust of the earth gets stretched too thin, the mantle, which is the part of the earth where the magma lives, will be really close to the surface and will start to flow or vent out onto the surface. And this is what happened in the Havala Basin over 300 million years ago. Past production from a deposit of this type came from the Big Mike deposit. The Coronado project is just north of Big Mike and is actively being explored by geologists today. Both are shown together on this map. Use a metallic ore deposit symbol and place Big Mike and Coronado on the Brownie. Compressional forces would pick up again later during the Pennsylvanian and would intensify and persist throughout the rest of the Mesozoic. This would result in something much bigger than the closing of the Havala Basin, the construction of Pangaea, a supercontinent where most of the land masses across the globe were smashed together, creating one gigantic landmass. So you can think of plate tectonics as a conveyor belt. If one plate is crashing into and subducting under another, any islands on that plate will be slapped onto the side of the plate it is crashing into. These terranes that are slapped onto the continent are called exotic terranes. Numerous exotic terranes were accreted onto the continent during the Mesozoic. In Nevada, 8 different terranes were added to the mass of the state, ruining oceanfront property every time they arrived. A generalized map showing these exotic terranes is displayed on the screen to the right of the red Nevada outline. Some of these terranes will be discussed soon. Before we move on, let's take a fact break. So if we look at the Earth's 4.6 billion year geologic history and scaled it to the calendar year, this is how it would look. During the last slide, we were looking at the late Pennsylvanian, which begins roughly on December 8th, which is National Brownie Day. And food for thought, the first fossil of a Homo sapien is dated back to 1 million years ago, or 11:02 p.m. on December 31st. Brownies were invented in 1893 in Chicago. That would be the last 0.54 seconds of December 31st, approximately 6 seconds after modern man had evolved. Okay, back to the show. The earliest terrane that would be formed in Nevada due to this rejuvenated compression would be the Golconda thrust sheets, which consist of deeper ocean sediments that were pushed up and over shallower water sediments, similar to what happened during the Antler orogeny. Rocks in the southern Hot Creek, Tobin, and Shoshone ranges are part of the Golconda terrane. Use the morsels to put these mountain ranges on the Brownie map. Remember those northwest faults I made a big deal about, a few of which I had you place on your map? Well, these compressional events reactivated some of these big, deep-rooted fractures, preparing them for use when our mineralizing fluids appear here shortly. The large landmass of Pangaea that existed during this time underwent a transition from a tropical, more jungle-like environment to a very arid or desert-like environment in the Permian, when the biggest extinction event ever recorded in Earth's history happened. Falling sea levels, an arid desert environment, and tectonic activity during this period created large puddles of water trapped in a hot inland with nothing else to do except evaporate. When water evaporates, minerals deposit, and out in the wild, salt, gypsum, borate, and other evaporite deposits will form. Currently, deposits formed by this manner of this age are being mined in Nevada, like Pabco gypsum. Use the non-metal symbol to put Pabco gypsum on your Brownie map. By the late Triassic, most mountains had subsided from earlier compressional events. In central and western Nevada, these rocks were below sea level and were being covered by younger marine sediments. Triassic-aged rocks host our state fossil, the ichthyosaur. Ichthyosaur fossils can be seen by a visit to Berlin Ichthyosaur State Park outside of Gabbs, Nevada. Put the appropriate symbol for place of interest on the Brownie to note the location of Berlin Ichthyosaur State Park. In southern Nevada, the land was being lifted upward due to tectonic forces, and as a result, dried up. Silt, sand, gravels, and mud were deposited. By the early Jurassic, a vast desert, probably similar to the Sahara, prevailed, and a thick sequence of sandstone was deposited. These desert conditions persisted through the Cretaceous. Aeolian or wind-blown sandstones are mined from Simplot silica and Rainbow Quarry in Nevada for decorative rock and for silica used in the manufacturing of glass, for metal casting, and much more. Use a non-metal symbol to place Simplot silica and Rainbow Quarry on the Brownie. Sometime during the Jurassic, a tectonic plate called the Phaleron Plate began subducting underneath the North American Plate. A small portion of the North American Plate is what we have been focusing on this whole time. The terrain we are sitting on right now, as long as you are tuning in from the United States and Canada, is part of the North American Plate. All terranes accreted to present-day northwestern America have all come in on the back of the Phaleron Plate. As subduction really kicked into action, the subducting Phaleron Plate eventually reached depths in the mantle where melting of the surrounding rocks began. From the Jurassic through the Cretaceous, these melted rocks made their way towards the surface, cooling underground, making them plutonic intrusions, and expelling their fluids into the surrounding rock. Many intrusions utilize those old, now reactivated basement faults. Fluids from these intrusions were responsible for copper, molybdenum, gold, silver, magnesite, and tungsten deposits mined in Nevada. The Robinson, Mineral Ridge, and Premier Magnesia deposits all formed during this time. Use the metal and non-metal markers to put these three mines on the map. Not only did ore fluids from these intrusions make ore deposits of their own, but they added iron to the rocks that would be needed to make the future Carlin-type gold deposits. The intrusions also created the Sierra Nevada batholith. We will come back to both Carlin-type deposits and the Sierra Nevadas shortly. During the Cretaceous, Nevada was drastically affected by the severe orogeny. This event added to the complexity of Nevada's geology, shortening Nevada 22 to 45 miles. During the severe orogeny, Paleozoic rocks were carried from the west to the east and pushed up and over the top of the Jurassic-aged sandstones mentioned previously. One exposure of this thrust fault is located in the Spring Mountains and is referred to as the Keystone Thrust. The Keystone Thrust is one of the best exposed thrust faults in the western United States. Use the morsels to place the Spring Mountains on your Brownie map. Brownie map checkpoint. Here's what your Brownie map should look like at this time. During the late Cretaceous, the subduction angle of the Phaleron plate began to flatten. Yes, subduction angles change, and when they do, activity associated with subduction changes as well. Flattening of the subducting plate caused a large plateau-like feature that was generated during the severe orogeny to be lifted upwards. This area is referred to as the Nevada Plano. This large uplifted area created a large drainage basin. River and stream sediments preserved on the Nevada Plano are evidence of its existence. Drainage directions, as recorded in the rocks, indicate the Cretaceous position of the continental divide. So the west side was draining into Colorado and the east side to the Pacific shore. Place the Paleocontinental Divide on the Brownie map. Rivers in this drainage basin would later cut into the Sierra Nevada granite and its lode gold ore deposits, creating the large gold deposits of the Sierra foothills. Discovery of these placer deposits in 1849 resulted in a large migration out west. Some of these prospectors made the discovery of placer gold in Nevada, which led to the discovery of the Comstock lode and the beginning of mining in Nevada. The Paleocene through most of the Eocene was tectonically quiet due to flat slab subduction throughout Nevada until the subduction angle of the Phaleron plate steepened again, resulting in the reintroduction of the hot mantle to the base of the North American crust, and things started to be pulled apart. This would be the early extinction phase of Nevada. Volcanic activity was associated with areas of early extinction, which produced hydrothermal fluids rich in gold. These fluids would make their way towards the surface through those old reactivated structures, and the iron within them would chemically react with the fluids and the gold would fall out. This pulse generated Carlin-type gold deposits. Carlin-type gold deposits are responsible for most of the gold currently produced in Nevada, making Nevada the 5th largest producer of gold in the world. The Carlin Trend, Jarrett Canyon, Turquoise Ridge, and Cortez are all Carlin-type deposits. Use the metallic mine symbol to put these mines on the Brownie map. Brownie map checkpoint. Here is what your Brownie should look like at this point. Let's discuss. So for the most part, all we have been talking about for the past couple 100 million years is compression, compression, compression. Look at your map, and in general, what do you notice about the mountain ranges? If you noticed that they are mostly trending north-south and have openings or what we would call basins in between them, you would be correct. But if compression has dominated up to this point, then why are there still openings? If you said because we are placing the features on the map as they appear now, you would be correct. So then something has happened since all the compression took place. Let's see exactly what that was. Around the same time the Carlin-type gold deposits were forming, a new tectonic environment was about to dominate and change the landscape of Nevada. The oblique movement of the Pacific Plate relative to the North American Plate caused the subduction zone to be cut off and a transform boundary to emerge. A transform plate boundary is where two plates are sliding past one another. The west-northwest pole of the Pacific Plate resulted in the extension of the North American Plate and ripped Nevada open, separating the ranges, leaving the basins in between, similar to what you see on your Brownie. This is why Nevada is often referred to as the Basin and Range province. Remember, extinction can put the mantle with all its glorious magma closer to the surface. Therefore, extinction is and was accompanied by volcanism that generated thick sequences of lava flows, ash, and, you guessed it, more mineralization. This time, mineralization was in the form of veins containing gold and silver. The core Rochester silver mine, Nevada's leader in silver production, Round Mountain, and the Comstock deposit in Virginia City are all deposits that were generated during this event. Use the metallic ore deposit symbol to put these mines on the Brownie map. From these volcanic events, lots of ash was deposited into lake beds. A type of algae referred to as diatoms use silica to make their skeletons, and as luck should have it, ash has lots of silica. Massive diatom blooms resulted in deposits of diatomaceous earth that are currently mined and utilized for filtration agents and organic pest control, among other things. Use the non-metal symbol to put the basalt and collado diatomite mines on the Brownie map. Several mountain ranges are made up of thick sequences of volcanics such as the Jackson Range, Seven Troughs Mountains, and the Kawich Range. Use the morsels to put these mountains on the Brownie map. To visualize how much volcanic material can be generated during these kinds of events, let's look at an example. The Kawich Range consisted of a complex of 5 calderas, which is a fancy word for a large volcanic crater. These calderas discharged at least 200 cubic miles of ash across an area no less than 12,000 square miles. That area would cover most of Nye County. 200 cubic miles of ash would be about 51 quadrillion brownies. Extinction also resulted in the uplift of some long-forgotten Precambrian rocks in the Ruby Mountain Range and the Snake Range. Also, extinction resulted in the uplift of the Sierra Nevada batholith, which formed our beloved Sierra Nevada mountains. The batholith that formed back in the Jurassic to the early Cretaceous finally sees the light of day here in the period of extinction. Put the Ruby, Snake, and Sierra Nevada mountains onto your Brownie map. Let's talk a little bit more about the Basin and Range province. The Basin and Range province includes most of Nevada. East-west extension has resulted in approximately 99 north to south oriented mountain ranges with associated active faults. Movement along these faults is still taking place. Nevada has been stretched in some places as much as 100%. The masses of faulted rock tower over the down-drop basins. Sediments eroded from these ranges fill the basins. Some basins have over 10,000 feet of sediments, and the alluvium, or sediments in the bottom of these basins, serve as sources for aggregates used for construction purposes throughout Nevada. And since extinction places the crust into close proximity with the mantle, it should be no surprise that things are a little bit hotter here in Nevada. Hot circulating fluids allow for the generation of geothermal energy. Nevada is #1 per capita and #2 in terms of generation of electricity to the grid in the United States from geothermal energy. Let's place some symbols for the San Emilio, McGinnis Hills, and Wild Rose geothermal energy plants on the Brownie map using the appropriate markers. These points represent just 5 of the 25 geothermal plants located here in Nevada. Moving onward in time, let's touch on the last ice age. The last ice age began about 2.6 million years ago and lasted until about 11,000 years ago. Contrary to what one might think, during the last ice age, Nevada only had glaciers on a few of its highest peaks. What the last ice age did result in here in Nevada is a significant increase in rainfall that formed many pluvial lakes throughout the state. A pluvial lake is a body of water that has accumulated in a basin due to increased moisture availability from changes in temperature or precipitation. The largest pluvial lake that formed during this time would have been Lake Lahontan. Lake Lahontan covered 8,610 square miles, which comes out to about 35 trillion brownies, and was over 500 feet deep. This is comparable to the size of Lake Erie in the Great Lakes region. Sand deposited along the beaches of the pluvial lakes are the sediment source for wind-blown dunes like Sand Mountain found here in Nevada. If you would like to visit a cool place to explore the last ice age, Tule Springs Fossil Beds, which has mammoths, lions, and camels which once roamed the wetlands surrounding these pluvial lakes, is located down by Las Vegas. Place the appropriate marker for a place of interest to mark the location of Tule Springs National Monument. As the climate warmed, the large pluvial lakes started to evaporate. As water in the playas evaporated, minerals precipitated and left deposits of gypsum, salt, and borax here in Nevada. Use the non-metal mine symbol to place the Adams Claim gypsum mine and the Huck salt mines, which are currently being mined today, on the Brownie. Not all brine escapes the confines of the basin by evaporation. Some brine lurks below the surface. The only lithium mined in the United States is from Nevada and is extracted from lithium chloride-rich brines that are contained in a volcanic ash layer. The brine has to be pumped out of the ground and forced to evaporate on the surface before being processed to get the lithium out. The geography you see on the screen is basically what we still have now, minus some water. It took billions of years and lots of major events to get to where we are now, and billions more lie ahead, at least for planet Earth. Well, here we are, and this is one final look at our map of Nevada on a Brownie. We hope you have enjoyed this video, and we really hope you enjoy eating your map. Be sure to check out our other educational videos by visiting the URL or scanning the QR code shown on the screen. Have a great day.